Hi, we're Team 4. Before we start, let's get to know our members. So let's us get started. Hi guys, meet Evianie Bingak Edward. These are her teammates, YANCE, SHIXUAN, ZHENG PENGFEI, and ADARSH BHAGYANATHAN. We are from Presentation Amplitude SHIXUAN, Biomedical Devices Implants. Without further ado, let's get started.
Hello everyone, welcome to our video. Our video is talk about ASK, Amplitude Shifting. Amplitude shifting is a form of amplitude modulation that represents the digital data as variation in the amplitude of the carrier wave. In an ASK system, the binary simple the amplitude carrier wave and fixed frequency for a bit duration of t seconds. If the signal value is 1, then the carrier signal will be transmitted. Otherwise, a signal value of 0 will be transmitted. The next one is ASK system. ASK system can be divided into 3 blocks. The first one is the transmitter. The second one is the linear model of the effects of the channel. And the third one is shows the structure of the receiver. The next is the ASK modulator. ASK modulator block diagram composed of the carrier signal generator, the binary sequence from the message signal, and the band-limited filter. Following is the block diagram of the ASK modulator. And the carrier generator sends the continuous high-frequency carrier. The binary sequence from the message signal makes the unipolar input to be either high or low. The high signal closes the switch, allowing a carrier wave. Hence, the output will be the carrier signal at high input. When there is low input, the switch opens, allowing no voltage to appear. Hence, the output will be low. Next is our applications. We use the ASK for the bioimplantable communication device. Medical care day by day and more is associated with the related concept and the advance of electronics and the electromechanics. Numerous medical devices are implanted in the body for medical use. Tissue implanted devices are of great interest for various medical applications due to the promising of different clinical usage to promote patient independence. It can be used in hospitals, healthcare facilities, and home to transmit patients' measurement data, such as pulse and respiration rates, to a nearby receiver, promoting greater patient mobility and increased comfort. In general, various telemetry, bio devices, and biomedical implanted devices mainly consist of 2 parts: an external located outside the human body and an internal part located inside the human body. The external part is used to supply power and transmit the data to the internal part through the inductive coupling link, as well as monitor the data from the human body, details of the data transmission between the parts. As you can see, this is a picture and can show the parts. The biomedical implant devices can communicate with the exterior world by uplink and using inductive wireless coupling or UHF links to transmit data from the body which is received in sensors. Most bio devices are bidirectional systems with the transmitted RF signal carriers either swallowed or surgically implanted in the patient. And the communication between the 2 parts is possible even through the different media such as biological tissues like fat, muscle, blood, bone, and so on. And this is one example of the ASK modulation for cochlear implants. And there is the introduction about these implants. And there are the characteristics of the implantable devices. The first one is low power consumption. The second one is high reliability. The third one is low voltage signals. And the fourth is low frequencies. And the last one is small size.
Moving on to the history and implementation of ASK in biomedical implant devices. ASK modulation was developed by the American electrical engineer Edwin H. Armstrong during the year 1930s. Biomedical implantable devices have been available for more than 60 years. The first transistorized biomedical implant device was designed and developed by Earl Becken in 1957 for cardiac pacemaker. Researchers are working on issues of biomedical implants to ensure patient safety and comfort. Moving on with the implementation part, the amplitude swift keying is the simplest digital modulation used in wireless telemetry bio devices and biomedical implant devices. In this type of modulation, no carrier is used during the transmission, which minimizes the power consumption of the modulator. In general, ASK modulation is used in the implanted part for its simplicity and low power consumption. Now looking at the ASK modulation for endoscopic implants. In wireless capsule endoscopic systems, the data transmission from inside to outside of the human body is high to achieve high-quality medical images. So, in order to achieve a quality internal biomedical imaging, in the year 2006, few scientists have proposed a pseudo-differential stacked Class A power amplifier based on a phase-lock loop and a RF conversion circuit. Therefore, in the system, a 3.62 mm square chip area of 3.17 mA power consumption ASK modulator is used to generate the low power frequency carrier by a voltage controlled oscillator and convert the low frequency ASK signal into the 2.4 GHz industrial, scientific, and medical band.
Let's look at some recent advancement of implanted medical devices. The first one is cochlear implant. It is an electronic device that partially restores hearing, and it has 5 parts, which are microphone, speech processor, transmitter, receiver, and the electrode array. And last year, FDA clearance of 3 new products, which can connect to smartphones to tracking hearing information and control the device. The second one is neural implant. A neural implant is a device placed inside the body that interacts with neuron. One of the most established clinical uses of neural implants is in a treatment called deep brain stimulation, or DBS. In this therapy, electrodes are surgically placed deep into the brain, where they electrically stimulate specific structures to reduce the symptoms of brain-based disaster. And DBS is used to treat movement disorders associated with Parkinson's disease, essential tremor, dystonia, and other neurological conditions. In 2018, patients who had been paralyzed due to spinal cord injuries walked again with the help of spinal stimulation. Next are the benefits. Implanted medical devices are very important electronic devices because of their usefulness in monitoring, diagnosis, safety, and comfort for patients. And also, implanted medical devices have the ability to selectively activate the grouping of fibers within the nerve and theoretically provide more selective control and balance of motor response.
As we know that the patients could benefit from the communication implants. Unfortunately, myths and misconceptions about the communication implant abound. So, many patients don't know the device is an option for them. Misconception on any potential risks which might occur regarding the topic in terms of health, safety, legal, or cultural issues. For the health issue, we often heard that people say that the implant can cause us an infection and it is hard to remove once it has been inserted. In fact, health providers who insert implants have been specially trained to insert the implant. So, infection can occur after the implant has been inserted, but this is very rare. And none of the studies stated specifically set out to investigate the cancer risk of implanted microchips. And next, safety and privacy issue. People always say that communication implant, for example, microchips, can track our location and store our identity. Actually, all the microchips implants are passive devices and have no battery inside them. They also have no GPS capabilities, so it cannot track your location. There are also other potential risks and other concerns regarding to the communication implant. Risk to human freedom and autonomy. What society is scared about is, in such a world, self-determination, the ability to think freely, and all personal autonomy would be completely lost. Human beings would be essentially digital slaves to government, corporations, or networks that own the microchipping technology. For legalism, some of the countries make it illegal to force a person to have a microchip implanted. For cultural issue, some of the religions and cultures not allowed to have any ICT implant. They think that transhumanism is a movement related to the implants and their relation to transhuman qualities of which microchip.